Hello and welcome to another video. In this video we're going to be continuing on with the TypeScript line 75 and we're going to be doing number of islands. So in this problem you're given an m by n binary grid which represents a map of ones and zeros and you want to return the number of islands. An island is surrounded by water and formed by connecting adjacent lands horizontally and vertically. You may assume all four edges of the grid are surrounded by water. So in this example our island would be, and we can actually make it bigger better. There you go. So if you actually take a look at where our islands is, this is an island right here, and that's the only one, so we just return one. And in the second example, we have an island here, here. So we want to return 3. So the actual algorithm for this problem is really straightforward, and there's one of two ways you could do it. Essentially, you loop through every number, and as soon as you hit an island, right, like a 1, the first way to do it is you just start a DFS from that 1 and you add 1 to the result. And let's kind of show what that would look like. Essentially, we would loop through, we'd be like, okay, we hit this 1 right here. We would just start a DFS and we would try to visit every single square that's a 1 because we want to make sure that we're not counting the same square as multiple islands. So we would start here, we would write, okay, we have 1 here, and then there's 2 ways you can do it. You can either put them all in a visited set, or you can actually just manipulate the input. I'm going to use a visited set because that's better practice typically, but if you want to know of one solution and you do manipulate the input, what you could do is simply you can just change all the 1s to 2s or something. So you would just start at this 1, you would do a DFS, and every 1 that you hit, you would change into a 2. And so now, once you did that, every single one of these ones would be a 2, these would be a 2, and this would be a 2. And then once you start at the next location, there are no more 1s, right? Every single one is a 2. So you would just get a result of 1. Similarly here, you would start a DFS over here. So I'm just going to, everything I cross over, pretend I made it a 2. We're going to go through all of this. This will be in one DFS, and we'll have 1 here. This will be in a second DFS, we'll have 1 here. And this will be in a third DFS, we'll have 1 here. So that's essentially it. Pretty much you just start at 1, 1, and then you go in every single direction, left, right, up, down. And if you hit another island, you just add to it. And essentially what you want to do is you want to cross off or mark every one that was next to the one that you visited in either a visited set or just change the number. That way, when you go to a new island, you will recognize that as a new island. So that's pretty much it. It's essentially just a DFS. Or you could do a BFS. Either one's fine. And I'm going to use a visited, I'm going to use a visited set. Because I'm not going to use a visited set because for a row and a column in TypeScript, you need to make keys and stuff. I mean, I guess I can use a map, but I'm just going to make a visited array that will literally be the same length as this. And it will all be zeros, so I will essentially make an array. It'll all be zeros, like a 5 by 4 array. And then every time I visit something, I'll just change that to a 1. So that's another way of doing a visited set or a hash map. Instead of that, you can just make an array that's the same size as your original input, set it all equal to zeros or false or whatever you want, and then when you visit it, just change it into a 1. I guess I can set it all to false. Maybe we could do that, yeah. So I'll make an array of this, set it all to false, and then when it gets visited, I'll make it true. But that's pretty much all the algorithm. The algorithm part is pretty straightforward. There's just a lot of code. So let's get into the code. Yeah, let's full screen. Okay, so we're going to make a rows and a column. So we're going to say constant rows, because we are going to reuse these values, and this is good practice to do, just like in my Python videos. So you want to make a length, you want to make a columns. And then you want to make a directions because you're going to be going, in every direction. So you're making directions arrays useful as well. So we can just say 1, 0. It's going to be nested here. But yeah, the hard part of this problem is literally just the writing a lot of code. It's not the actual algorithm. The algorithm is pretty straightforward. This 0, -1. So here we have all the directions. And now what we need to do is we need to make our visited array. And so it's going to be a 2D array. And so the way you could do that is you could do this. You make a new array. And it's going to be length rows. and we're going to fill it with something, and then we're going to map. And then what that essentially happens is, let's say there are 3 rows and 3 columns. Essentially, what you're going to do is you're going to fill it with like 3 nulls, and then you can just map every single one of these to make another new array of 3 more things. So these nulls will get replaced later, so that doesn't really matter. Then we can map, and then we can just give it a function that doesn't, we don't really need the input, we just need to make a new array. New array, columns, and we can fill it with false, maybe. Yeah. So essentially now we have an array that's rows by columns and it's all filled with falses. Now we're going to have our answer, our islands, call it islands result, whatever you want, 0. Now we're going to have our DFS function. So for our DFS, it's going to take a row, which is a number, column, which is a number, and it will return void, right? We're just updating islands, so we don't need to return anything. We just need to mark everything. We need to DFS from where we are and mark everything as visited. So we have an if statement here, and first we're going to check if our row and column are out of bounds. So if row is less than 0, there's a bunch of these, or row is greater or equal to rows, or call is less than 0, or call is greater or equal to calls, or so if we visit a 0, we don't really care. Also, the thing you have to notice in this problem is these aren't numbers, these are strings. So we have to actually check for a string here. So if it's a 0, we also don't really care. We just only care about ones we visit because we want to mark every one as visited. 0 doesn't really matter. So if it's 0, we can also return, or if it's already in visited, we don't care either because we don't want to do it again. So if it's any one of these, we can return. Oh, we have a problem here. There we go. Okay. So now what we need to do is we need to set wherever we are as visited. So we could say visited row column equals true. And now essentially we have to try to go in every single direction and call DFS again. So we could just say for let direction. Actually, we can use destructuring. I think it's a little bit less efficient, but because we're more focusing on like cool TypeScript stuff, we can do destructuring here. So if you want to go through all your directions, you can actually say like this. And essentially what this will do is this will loop through every single inner array, and it will destructure the first and second variable to be the updated row and column that we're going to add. So we can do that, and then we can just say DFS of row plus R and call plus C. Because these are the values you need to add, right? Like this is down, this is right, this is up, and this is left. Okay. So essentially that is the entire DFS. And now we actually have to loop through our islands, and for every single starting location, we need to call a DFS, right? And it's not for every single starting location, it's for every single starting location that's a 1 that we haven't visited before, because we are using visited in this case instead of the string itself. Or string array itself, but you can use the string array itself if you want to as well. So essentially you need a nested for loop here. Row is less than rows, row plus plus. And that's why I also like using like rows and columns, because I think this is a lot more descriptive. It's a lot easier to figure out what's going on here instead of using like INJ or something. Say, and then calls, call plus plus. So essentially what we need to check is if it's a 1 and it hasn't been visited yet, then we are going to update our islands and just call DFS from that location. And what that will do is it's going to try to visit every single one that is connected to that one to mark them all as visited. So that way when we get to those, we're not going to count those as duplicate answers, right? We're going to get every unique island. So if grid row call equals 1 and it's not visited, so not visited row call, then we can increment islands, and we can also just DFS from there. And so this will get every unique island, and that is pretty much it. Now we just need to return at the very end of this thing. And there we go. So decent amount of code, but as far as the actual complexity, not very hard. Literally just start every island, and like I said, either DFS into a visited array um, or visited. You could use a visited object, or you could just write over the grid itself. Any one of those is fine. I would say though, like writing over the grid is not the best practice though, so I would talk about that. If you are getting this as like an interview question, I would ask if you're allowed to do that. Okay. And I think it's a little bit less efficient because I use this thing. I think if I actually write this in a using like a normal I, then it'll be faster. But it's still not that bad. Because I do think, yeah, like I don't know how much of a difference it'll make in Linko tests. I know this is generally like a slower syntax than using an I and just like iterating to the length or something. This is like the slowest way of doing a for loop, I believe, in performance for JavaScript or for TypeScript. So, but it just looks cool. So, yeah, that's gonna be it for this problem, except for one more thing. So, we can go through the time and the space. So for the time, let's kind of walk through what we did again. So this is all O1. This making the array is going to be m by n already, right? Row, stems, columns, because we're making it. Then for DFS, we're not really visiting, we're not visiting the same place twice, pretty much, because if it's already been visited, we're just returning, right? We're not like doing multiple things. So essentially what will happen here is this DFS thing will only maximally go to every single location once. I mean, it will technically recurse, but it'll just return right away, right? So you'll go somewhere and then you'll return right away. So that's pretty much negligible. Now this part, yeah, I mean, basically, yeah, the DFS is just going to be rows by columns. And then this part is also going to be rows by columns. Yeah. So pretty much we're going to have rows by columns here for the time and the space here, because we aren't like recursing anymore. If we visited, we're not going there again. It'll technically be a little faster because not everything is going to be a 0, right? So worst case, everything is 1, then it will be the slowest possible thing, but otherwise it'll be a little bit faster. But yeah, this is worst case. So, and then for the space, we do have this visited array, which is the same size as the actual grid. So that's also going to be rows and columns. Let's see if we have anything else. So we have an array. These are all just constant variables. So we have our DFS. So we can think about like the recursive call stack as well for this DFS. And so worst case scenario, I mean, the most you can ever like recurse is also rows times columns. So that's going to stay the same, like assuming you had some 3x3 and you went all the way down somehow. That would also be rows by columns. And then this doesn't cost anything. So yeah, so it's going to be rows by columns, worst case recursion stack space, and the array is also rows by columns. So this is just rows by columns. And yeah, I think that's going to do it for this problem. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.